Okay, so yesterday we learnt, what did we learn actually? I shouldn't tell you, you should tell me. What did we learn yesterday? Tell me something. Daniel, what did we learn? We learned only 3 things yesterday. 20B, 20C. Can't remember anything.
I tried to do my own.
Really? Okay, then I'll help you on the side. What did we learn, Ben?
We learned scalar product. No, not scalar product. Scalar product, yeah.
Scalar product or dot product is what we learned.
Yeah.
We also learnt in 20B. What was in 20B? William Mason. 2 things. 2 things in 20B. I'll give you hints. Components. Fantastic. That's it. So we're just saying that in a vector, you can split it up into 2 components. You have a horizontal component, you have a vertical component, and you called the horizontal I and the vertical J. Okay, so that was the first thing you did. So that was 20B, but then an extra part to 20B. So once you break it up into I and J, there was also an extra thing that you learned. What was it, Saba? It is something to do with the magnitude, yes. What's to do with the magnitude? 20B, one more thing. One more. The?
Unit vector?
Unit vector. What is a unit vector? Can I please have Rose? What is a unit vector? Yes, it is a vector with magnitude of 1. So same direction. Okay, every time you write a vector. So let's say we'll make up a vector called A. Vector A, let's call it I plus J. Okay, so 1I plus 1J, right? So if I drew that, this is what it looks like. It has 1I unit, 1J unit, and this is my vector. So if you ask what the magnitude of that is, so magnitude of A, you'd say it's 1 unit by 1 unit. So Pythagoras' theorem tells me 1 squared plus 1 squared, square root of that, and that gives me root of 2. But I don't want a unit length of 2. What if I want to know what the unit length of 1 is? Okay, so I want a unit vector of that. I want the length to be 1. I don't want this to be root 2. I want that length to be 1. Okay, not root 2. So how do you make it 1? Makes sense that if you just took the unit length A divided by root 2. Because magnitude of A divided by root 2 would naturally give me 1. So the formula that you have is, if this is the unit vector, if that is the vector that has a unit length of root 2, then all you have to do is say, all you have to do is just take the vector A divided by root 2, or in this case, magnitude of A. And we call that the unit vector. So that's what we learned in 20B. Okay, so it was all logical, and we can say the notation for it is A hat, which is unit vector. Unit vector just means magnitude of that vector is 1. All you have to do is divide by its magnitude. Okay? Then you learn 20C. We learned scalar product. There were 2 formulas for the scalar product. What were the 2 formulas for the scalar product? Give me one of them, Jamie.
AB cos theta.
AB cos theta. What are we missing? It is correct. Those are all correct. We're just missing something. Yep, the vertical lines. What do the vertical lines mean? Magnitude. So we're saying modulus of A, or absolute value of A and absolute value of B, or magnitude of A times the magnitude of B. Because remember, you're talking about the lengths. Okay, you're talking about lengths overall. When you multiply 2 vectors, you're getting a length. Okay? Now, you got magnitude A times magnitude B times cos theta, but if you don't have an angle, how else can you do it? There was 2 formulas to this. That was the second one. Hey, Michael, you made it. Maybe he does have some bit blood. All right, so what's the second one? There's another one. One more. What was it again? Fantastic. The components of I, because we said there's a horizontal component and a vertical component, well then the horizontal component of A, which we call A1, times the horizontal component of B, plus the vertical component of A, which we call A2, and the vertical component of B, which we call B2. Okay? So those are your two formulas that you learnt yesterday. But I wasn't interested in just giving you formulas. I could have done that in 5 minutes and just said, do. What does it mean? That's the final part. Because that links onto today. The meaning of what you were doing here. Okay, so what does it mean? When you say vector A times vector B, what was I trying to describe yesterday? What does it mean? What does it tell me? A dot B. What are we effectively doing? What are we effectively doing? Can someone describe to me? Phoebe? What's A dot B doing again? Okay, so your hand gestures are correct. Ben, can you describe what her hand gestures were? Okay, yeah.
Magnitude of A squared.
Along with those ideas, yes, that is true. But no, what your hand doing was correct. Magnitude of A squared is a specific type. Magnitude of A squared is actually A dot A. That's where I started off. I started off by asking, what does it mean when you do A times A? And why the answer, well, I used 3 yesterday. I said 3, magnitude of 3 times 3, and I proved to you that both of them meant the same thing. But I wanted to know, what does it mean when you say A dot A? Vector A times vector A, or vector A times vector B? Ben? Yes, that's what you're doing. You're multiplying. It's not, yeah, in our case, it is horizontal. But what you're really doing is, remember, you're going to get 2 different types of vectors. You're going to get one, let's call that A. Whoops, I'll draw it a bit better. This is called vector A. When you multiply it to vector B, okay, you can't multiply 2 things that are different. It's like saying I'll multiply the number of 3 pigs versus 3 cows. So unless I group them together and say that they're animals, then I say, well, I've got 3 groups of pigs and then somehow times 3 groups of 3 cows. It doesn't work. The only way you can times them is if you had the same units. So that makes sense. If you have 3 pigs and you want 3 groups of pigs, it has to be 3 groups of pigs for you to go 3 times 3. You can't just say, I've got 3 groups of cows here and I've got 3 pigs here. Let's see how many groups I have. It doesn't make sense to have pigs and cows together. You can't say 3 times 3 is 9. Okay, you don't say 9 pigs and cows. So the only way to work is if you have the same units. So same thing with this one. You can't say, I'm going to multiply vector A with vector B when they both have 2 different components. So what we can only do when you multiply vector A and vector B is you're multiplying the similar components, which is why I times the I, which is vector A times vector B, that makes sense. You can multiply these 2, adding with the components of the vertical components of A and vertical components of B. So effectively, what you were doing with the formula was this. You're actually just finding, you're actually just finding this. When you write A, which is vector A, B cos theta, technically it should have been B times A cos theta there, but it doesn't really matter. The whole point is, if you want to find this length right here that I'm sort of drawing over, you would say that this is equivalent to A cos theta, magnitude of A. Okay, because in order to find this length here, this is just trigonometry. This is your cos length. This is your hypotenuse. Okay, so you would say that this is equivalent to whatever the hypotenuse is times cos of theta. Gives you this length. Now they're both in the same direction. Because they're both in the same direction, you can say this times the magnitude of B is what you're actually doing. And that's what this formula is saying. So this formula is just simply saying, if you just rearrange it, it's just saying magnitude of B, which is the length of what the horizontal line, or the direction you have, times the same direction that you have. And that gives you what A times B is, vector of A times B. It should be a longer line. Okay? What I was talking about yesterday, which is what you mentioned there, A dot A, was I was saying if you have the same length, if A was 3, I gave an example, I said if A was 3I, so it's just 3I, it's just the horizontal length of 3, then naturally, if I asked you what A times A is, but they're both in the same direction here, so 3 times 3 is 9. And I proved to you that it worked out to be 3 squared, which works out to be 9 as well. Okay? And that's what I was trying to show you yesterday. Does that make a bit more sense now? Yeah? 20B, 20C. Broke it up to components. And because you've got components, when you multiply them in the scalar product, you've got vertical components with vertical components horizontal components with horizontal components. Cool? All right, now today's lesson. It's the same thing. Okay, same idea. Today's lesson, we're going to take vector A, okay, and what we've done so far was we did A times B in exercise 20C. 20D is a new term, we call it vector projections. Is what you're trying to do is you're trying to find this actual length. You're just trying to find this vector. So vector U with this actual length and vector W with this actual length. Okay, that's all we're trying to do. And we call this a projection. So we're saying that if this is A, obviously A is made up of two components. It's made up of a horizontal component and A is made up of a vertical component. Okay? But this horizontal component will be the same direction as B. The only difference is it's smaller than B by a factor. We don't know what that factor is. It could be half of it, it could be a third of it, it could be a quarter of it, right? But we're going to write this down. So let's write this down. Well, the things I just said. I said A is made up of two components. It's made up of the vector U, and it's made up of a vertical vector W. Okay, so you got U, you got W. And I said that U is in the same direction as B. The only difference is it's multiplied by a factor. I don't know what factor it is. It could be double of B. It's unlikely to be double of B, but let's say it's in that direction. So U could be half of B. It could be a third of B. But how can I generalize it? I can say it is K of B, because I don't know what that factor is. It's K multiplied to B. Does that make sense so far? No dramas? We're all pretty good. So I'm just saying vector A can be broken up into two vectors. U plus W gives you the vector of A. Now I'm just saying vector U is in the same direction as vector B, just like what we did in 20C. Now, in 20C we said there had to be a component of A. We knew this was magnitude A, cos theta to give you U. What if they didn't give you an angle? How do you find U? That's what we're doing today. Okay, so if they didn't give you an angle, how do you find the vector U? The vector U, we're writing it as this. We're saying it's K, it's a factor of K times your vector B. That means you can also write W with what Jamie mentioned yesterday. If you want to find vector W starting at this point, you go in the opposite direction of U, which is negative U, plus the direction of A, that gives you vector W. True? Yeah, so this is W is negative U plus A, and that gives you vector W. So now if I rewrite this, the components of, this is using 20B, writing the components of A into some lines or some vector lines. What I have so far is I got U is equal to some factor of B, and I've got W, which is negative U plus A. Okay, so now I've got these components. Our goal is to figure out if I was to be given just vector A, vector B, somehow I can find vector U. That's what I want to do. Okay? I've got two formulas and I've got two unknowns, or two of the U's that I want to figure out. So what I can do now is I can say this. What we can see is W is perpendicular to B. Okay, because W is always the vertical component, so it's always going to be perpendicular to B. If it's perpendicular to B, one of the things we learned yesterday, which I mentioned, if you have them perpendicular to each other, this is vector A and this is vector B, and we said A dot B, what should that equal to if they're perpendicular? Why is it 0? It's true.
Cos 90.
Yes, because of either the formula you learnt before was A dot B equals to magnitude A times magnitude B times cos of theta, but the thing is cos of 90 degrees, we know that cos of 90 is 0. And 0 times all of this, it's going to give you 0. Okay? Now, not just because of that, but logically as well, remember I said when you multiply A dot B, what you're actually doing is you're saying, look at the components of A, multiply that, because you want to find it in similarity. You can't multiply two things that are similar. Right now, I've only got a vertical length. This one, I've only got a horizontal length. So, because they only have one of each, I can't multiply them. It's like saying pigs and cows. I can't multiply them. You can't do anything about it. So there's 0 commonality. That's the same thing here. You're just saying A times B, well, there's nothing to multiply to, that's why it equals to 0. So therefore, W times B should also equal times 0. Okay, because it's perpendicular. Now the nice thing is I can rewrite W. I can rewrite W as negative U plus A. But negative U, so this is plus A. That's my positive A there. Negative U, which we wrote here as KB. So I'm just replacing them all. Okay, so I just draw an arrow so you can all see. I'm just replacing. So this is my A. This is my U. Yeah, this was negative U, which is, I'm just putting it in here. Okay, that's all I'm doing. So I'm just replacing that W, writing that W over here, and I'm replacing U. Okay? So now I've got this. This is nice, because if I gave you vector A, vector B, we're almost there. We've got vector A, we've got vector B, we've got components of B, we've got components of A, and I can figure out U if I know what K is. Because U depends on K. So my job right now is to find out K, because I had two unknowns before. My job is to find out K, and this is possible. I can rearrange all of this, expand the brackets, and rearrange it to find K. And that's what I'm going to do. I'm going to expand the brackets. I did B times the A, B times the negative KB. Okay? I'm just putting these two in brackets because it's B times B. Okay, so you can see that, B dot B. My goal is to find K, because if I find K, I can find U. So plus KB on both sides. Okay, so I got K times B dot B, I'm plussing them on both sides. Now I've got A dot B equals to K times B dot B. Now if you want to find K, divide both sides by B dot B. Oh, now I finally found K. Now K is all in terms of A dot B. Uh-oh. A dot B over B dot B gives you K. And so that means now I know what U is. Because according to U, it was K times B. Now this is nice. So this is nice because now, if I have a vector A and a vector B, and I want to know what the equation of the vector of U is, I can find that now. Okay, and that will tell me the horizontal component of A. Just like yesterday. So yesterday you would have been able to figure it out if you knew the magnitude of A times cos of theta. But now you don't have an angle, so how do you do it? There you go. This is doing it without an angle. This will allow you to find U. Now we give that a name. We give that a name. So this formula has a name for it, and that U there, we call that the vector resolute or vector projection of A. We're projecting A in the direction of B. That means you can write it the other way around too if you wanted to. You can say vector B projected onto vector A. So you can find the vector resolute of B in the direction of A in the same way. The only difference is the formula will be the other way around. It'll be B dot A over A dot A times A. If you wanted to find vector resolute of B in the direction of A. Okay, it would just be the other way around. Okay, so that's all we're learning today. Literally, that. And we're just going to look into that formula. We're just going to break this apart, have a look at what each of these do, what do they really mean, and we'll give extra names to it. There's three names that you need to know. I've just given you the first name, vector projection or vector resolute. All it simply means is find the vector that is in the same direction as the one you're multiplying to. Okay, just find that vector. That's all it means. Okay, so really, it's sort of like they call it projection because you're taking vector A and you're projecting one of the components in the same direction as B. That's all you're doing. Okay, so it's linking down what 20B was, knowing that you have a horizontal and vertical component. 20C was trying to understand what A dot B was really doing, and the only way you can multiply two vectors is you multiply in the same direction. Okay, same components. And today, without an angle, you can actually find out that vector that A was projecting. Okay? Okay, now, things that we can say then, just another name to add. If we know that vector U, we could write that in terms of A dot B and B dot B times dot B, right? That means you can also write W. Okay, so if you can rewrite W, you've got U and W, we call that rectangle components. Okay, so finding U was called a vector resolute of A in the direction of B. If you find U and W together, you rewrite A, that's called a rectangle component. So copy this formula down, because sometimes the questions will say, find the rectangle components. Really, they're just trying to tell you to find both U and W. So both the horizontal and vertical components. That's all they're trying to say. Now, how do I get the formula? That's U, which we figured out already. W, which according to our formula over here, says W equals negative of U plus A. That's my positive A, and that's minus U. Same thing. Okay, so all I'm doing is just replacing them. I'm just replacing the minus U and positive A. Minus U plus A. That's my W. Okay, so I'm just replacing them. That's all I'm doing. So this U, I'm just putting it back here. And this, I just write over here. And that's just my U plus W. That tells me A. But the nice thing about it is I've rewritten vector A in terms of A dot B. Okay, so if I'm just given two different vectors, I can find the horizontal and vertical components without theta. And that's nice. Whereas the previous exercise, you needed theta to figure these out if you wanted to. Okay. How do we feel? That's 2 out of 3. That's 2 out of 3. So there's only one more thing that I need to talk about, and that's it. So you're just using three formulas, technically only one, but there's 3 formulas to sort of pay attention to, and 3 terminologies for 20D. Yeah? Now, what's that last one? Write this one down as well. These are all the possible ways that you can rearrange the formula. So we start off with this. A dot B over B dot B times vector B. We can rewrite B dot B as magnitude of B squared. That's what I showed you yesterday. I said A dot A is magnitude A squared. Yeah? So you can write it like this. Or you can break up magnitude B squared means magnitude B times magnitude B, both in the denominator. But why do they break it up like this? Why do they break it up like that? Because what do you notice over here? You see B over magnitude B, B over magnitude B. What is this again? I just revised it at the very start of this session. It is the? Yeah, it's a unit vector, which is why they wrote B hat. Now why do we want to look at this? If this is a unit vector, so I'm going to write here, if this is a unit vector, and you take another vector, so a vector times a vector, what does a vector times a vector do again? What does it tell you? When you take a vector times a vector, what does it give you overall? It tells you what? The length. Okay, so the magnitude, or not the it's the magnitude of A dot B in the same direction, right? So this is the unit vector. When you times it with another vector, you're getting a number. Just think of that. And that number represents a length. Interestingly enough, if that's a number times to a unit vector just means that you take a unit vector and you multiply it, or you extend it. That's all you're really doing. So effectively, this here just gives you a number. And that number is a factor. And that's a factor of how much you're going to extend your unit vector. Okay, and that makes sense because if you look at the diagram before, this makes sense. This is B, so that was vector B. But what you just figured out here was the one that we just said. It was A times unit vector B. This is just a factor of unit vector B, or vector B. Yeah? So that's the amount that you're going to multiply to this entire length. So you're just taking vector B, you're extending it by this factor of U. That's all you're really saying. So what I'm really trying to say is over here, this just tells you a factor. That just tells you how much are you multiplying to the vector B, unit vector B. Okay? So we gave that a name. Okay, so there's 3 names overall. This last name that you need to know, if they ask for what we call the scalar resolute, it's because we're looking at that U. This here just tells us the overall length in the direction of B. How much we're multiplying to the factor of B. That's my B direction, and that's how much I'm multiplying it by. And we call that a scalar resolute. So when they ask for a scalar resolute, you're still looking at the same formula. The only thing is you're ignoring this B. And you're looking at that. Okay, so effectively, this right here is your scalar resolute. That's what I'm trying to say. Okay, that is your scalar resolute. because that's how much you're multiplying to the vector of b. That's effectively how much you're timesing it by. How long are you extending it? Are you doubling it, tripling it, quadrupling it? What are you doing? Okay? And that's called the scalar resolute. So 3 things you learned today. What a vector resolute is, what a rectangular component means, and scalar resolute. Simple and easy. Okay? And the reason why I explain it so that, you know, I can easily have just given you that and given you this formula here and you'll be done. Okay, you can just go in and just do these questions here. They say find, you know, vector resolute of A in the direction of B. So you just do the formula, do A dot B, which is what you learned yesterday, and A dot B, and times that to B, and you would have been done. Yeah? But it's all about understanding what you're doing and how they all link together. So B, C, and D go hand in hand, understanding when you multiply 2 vectors, what are you really doing? Okay? But that's it. Have a go. I'll do the first one, you can do the second one. Okay, I'll do the first one here. So, let's have a look at this. I've got vector A times vector B. Find the vector resolute. So, think about it just kind of like you've got A and you got B, and you want to find the vector resolute, just means this. I'm just trying to find this. Okay, so it has to be some sort of vector. At the end of the day, this has to be a vector. So, let's work it out. According to this, I need A dot B and I need B dot B. Okay? So A dot A, let's work that out. A dot B. That just means, remember when you multiply A dot B, you had this formula, one with an angle, and one without an angle. This the other one was multiply the components, horizontal with horizontal, vertical with vertical. So if I look at this, I've got 1i multiplied to 1i, which is 1 times 1, which is 1. Yeah? Plus with, now I've got my vertical components, positive 3, times negative 1, negative 3. So A dot B should give me 1 minus 3, which is negative 2. Okay? And then I go with B dot B. B dot B just means that, you know, you've got itself, so 1 times the 1, which is 1. And then negative 1 times the negative 1, 1. It's 2. So, putting them together, my vector resolute, which is U, has to equal to A dot B over B dot B multiplied to the vector of B. Well, you just figured this out. A dot B gives you negative 2, divided by B dot B, which is 2, times B, which is I minus J. So this gives me an answer of negative I plus J. Voila! Now I found U. So U equals to negative I plus J. Vector resolute. Okay? And when they say vector resolute of B in the direction of A, they're really just changing the formula. The only thing that changes is, instead of it A dot B, it's now B dot A. And because it's in the direction of A, then it'll be A dot A times the direction of A. Do the same thing. You get A. In the second question, they say find the scalar resolute. The only difference with this one, remember, is you're only finding the factor. This is A dot B times B dot B. You don't need to multiply that to the vector B. Okay, that's technically what you just did over here. That's your scalar resolute. Okay, that just tells you the factor, which makes sense because our factor here was negative 1. Okay, so we call that a scalar vector. Oh, a scalar resolute, sorry. Yeah? And then after that, what's the next question? Find the rectangular components. There's only 3 things you have to learn. Rectangular components, you had that formula. If you can't be bothered memorizing it, then you can break it all apart. But I think memorizing is nice, just because it's quite a big one. You had what, A dot B over B dot B times B. That was for U, plus W. W was A minus the negative U, so minus A dot B over B dot B times B. Voila. There you go. That's your rectangular components. You had to work out this, you had to work out that. Simple and easy. Okay, and that is 20D. Pretty good. But I understand you have 20B, 20C, 20D. Some of you might still be struggling on 20C or 20B. So Monday, we're just taking our time to do this as well. You've got the weekend to try to pick up the gist of it. I'll recap you on Monday again what 20B was, 20C, 20D to make sure that you understand it before we move to 20E. Okay? And here we'll have some watching videos to do. Yeah. Okay? There we go. I'm going to pause the video.
Plastic potential.